Now, usually when we think about types, what we think in terms of is having a hierarchical relationship. So we have some types, we have a supertype, we have a subtype, and we know that subtype can be assigned to supertype, and so it goes on like that kind of mindset. Now, when it comes to TypeScript, we have to broaden this understanding a little bit further so we can get the right help or right understanding about the type system of TypeScript. So what we're essentially looking at, rather than having this hierarchical understanding, we are trying to broaden it to have more of a type set or the set theory based understanding. And that's way we don't need to think about direct relationship between a type, but more of a more broad understanding based on its structure. So that's where we use the term structural typing in TypeScript. We are more concerned about the structure of the value to assign that value into a type rather than more of a formal hierarchical connection between any of the types. Now, to get to this understanding, I have taken some of examples, a simple internal user type where we have some types you can assign admin, CS, and tester, and also another type external user. We have player, influencer, tester. And as you can notice, we have the tester as a common value we can assign to any of these types. So in its external user here, we have assigned tester. And we know for the external user, we can assign player, influencer, but we can't assign any other values because that's not part of its type. So that's we are going to start with. And then we are trying to build up more type models or additional types using these two types we have taken. Now, if you think in depth, this is more of a combination or a union of unit types, because if take admin itself as a type, that's a unit type. CS is a unit type, test is unit type. We are doing a combination of those types using union type to get the internal user, and same for the external user as well. Now, the things will be very interesting when we use the combinations of these types to build up more broader types or more additional types based on these starting types. Now, from this point on, we are moving to create a new type called all user. Now you can see in the all user, we are using the pipe or union type. We are combining internal user, external user using the union operator here. Now, the thing that we need to focus is getting this theory understanding, assign it with this set theory. It could be intersection here, or it could be just disjoint, but however we want to broaden that understanding of what expressed here in terms of types. Now you can see I have taken some reference from the UCL side about set theory, and you say A union B consists of everything which is either in A or B or both. And now here we are creating this new type, all user. We are combining internal user, let's say A, and we are combining that with the external user B. So here, what we are saying, we can assign any value that can be assigned to internal user, any value that can be assigned to external user, or any value that can be assigned to internal user and external user. So if we see in the set theory, it's a combination of something like this we have now. So we have this tester in the middle because that's common type, so that's the intersection, so that's come to or both case. Or we have the admin, let's say CS, and we have the player, and also we have influencer here. So this kind of visual representation that we are constructing here using the union type. Now the key thing we need to keep in our mind is this or both case, because that implicitly we need to understand by using or both that this or here is an inclusive or, similar to we are using with the bitwise operators in runtime. And having this little understanding explicitly can make things more simple when you come to combining more advanced types. And that's something we need to always keep in our mind when it comes to representing as diagrams as well. So in here we have the tester, and that's the or both case. Now if we take a value, let's say admin, the admin can be assigned to internal user, so that can be assigned to all user. If you take player, that can be assigned to external user, so that means it can be assigned to all user. If you take a tester, it can be assigned to internal user, and also it can be assigned to external user, so we can assign that to all user. That's the or both case. Now once we understand this concept using this simple types rather than we are moving to the objects at this stage, then we get better understanding how this should be applied to objects as well, because most of the time we are dealing with the object during the runtime of JavaScript. So we are trying to construct or get the utilization of type system from TypeScript to get the runtime aligned more perfectly with our intentions. And then we can move to the next section of understanding the intersection type. Now intersection type is not new if you remember the diagram we created here. So we had tester inside. So pretty much this intersection is talking about this both case. So we don't have these two cases, it's only the both case. So that's the intersection is about. Now in this example here in the UCL, they are talking about set theory. A intersection B consists of everything which is simultaneous in A and B. So this is A and B only part, which is again subset from the our union type. So if you think about the same way we talked through about union type, so that anything that can be assigned to internal user and can be assigned to external user, and that's the only case we have is tester here. So that's what we're doing in the intersection. We are completely focusing about the intersection of the set theory. Now if we follow up to this place of intersection type and the union types, you can understand that there can be a case there is no value that can be assigned to both A and B. So in this case, if you had intersection of internal user, external user, without having this tester, so that will become a set like this, which is we call as disjoint set. Now common case of this one is this example here. Now if we see 1 and 2, we have 1 and 2, and you can see it's been inferred as never type, which is the bottom type of TypeScript. And that makes sense if we explicitly follow the terminology or the mindset we built so far following this example. Anything that can be assigned to 1 and anything that can be assigned to B. So this and means intersection, so the value should be able to assign to 1 and value should be assigned to 2 as well, and we know there is no such a value, so that's the never type. So that's give the visualization of the disjoint. So we have 1 here, we have 2 here, so we can assign 1 to 1, but you can't assign 1 to 2, so there is no intersection here, so that becomes never type. And same with this example, if you see, if we get the or case 1 or 2, so that becomes the union type. So we have 1 here, little types, so you have 2 here, but there's a no intersection. So the only values we can assign here is 1. We can assign 2. And this part here we talk about or both is now optional because there is no disjoint, there is no intersection here, so it becomes disjoint. So that's something we need to understand as well, because there is a case even when you have a union type, a union type can become without no intersection. So we can't accept all the time that union types, there can be values assigned, and there can be a case of intersection that no value can be assigned, which is the disjoint case. But if we follow that same wording, something that can be a value that can be assigned to 1 and value that can be assigned to 2, and if we know that's the intersection, and then we can, without even using the type checker, we can infer in our head using the mental model what kind of a value we can assign to this type. Now with our previous example, now we have here internal and external user, which is the intersection. Now we can see the value we can assign is only tester, which is the intersection. So if I try to do player, you don't see any suggestion at all, but if you do the tester, we get the suggestion. So that means only value we can assign is tested there. And right, so with that, I think we pretty much covered the main cases just by using literal types. So no objects there. So this fundamental understanding, now we can shift to the objects. Now in this example, we have a player type. We can see the shape of that object, ID name, and we have admin type, same ID name, but extrapolative access code. Now we need to pay attention about the types we have here as well. So we have the number type, string type, number type, string type, and also string type, because the structural typing shape is about the property name as well as its type. Now let's start with these two types and let's build the models of intersection and union. Now if you see here, so we have the user type where we have player and admin. Let's assume there's an intersection for now. And then now we are dealing with object values. Now we can see, let's say this side is player and this side is admin. Now the mental model we need to bring here is, as we discussed with using the literal type example, values that can be assigned to player type, values that can be assigned to admin type. So I'm explicitly making that statement rather than focusing on the properties, because this is a structural typing system, and you will see if we follow the same terminology like the assignability terminology of values, that will make things very simple when we come to understand more complex structures of types. Now we have the union type of user. This time is a player and admin, and we are not going to think about any kind of property operations here, but we are going to think more in terms of values as we did with the previous example. So we have this sum of the object defined O1 with ID name, first one, and the second one we have ID name and extra property of A, and we have ID name and extra property of B. Now in this example, U1 is a user, we know it's a union type, so any value that can be assigned to player, or any value that can be assigned to admin, or any value that can be assigned to both admin and player. So we need to keep that in mind. Anything that can be assigned to both is a valid value for user type as well. Now O3 here, we have ID, name, and we got extra property B. And as you can see, still it's a valid assignment because it satisfies the ID and name, the structure of this object type. So we know we can assign this value, although we have the extra property B here, and we don't need that one because we only need the minimum requirements of ID and name. So we can assign that value there. And if you try to assign O2, That's fine as well, because in the O2 we have ID and name and extra property A. That's fine. And how about O1? O1 is fine as well because it's got ID and name. So that's where comes to the player. We can see any value that can be assigned to player, or any value that can be assigned to admin, or any value that can be assigned to player and admin, and this case is satisfy the assigning value to the player. So in the next example we got 04, 05, 06, and in that we have got some of the access code properties which is come to the admin type of values, and also we got this 07 which got lots of extra properties including a nested object. Now for the U2 user here we are assigning 06, which is totally fine because you got ID, name and access code, the minimum requirement you need for the admin, and also it has everything need for the player as well, ID and name. So this 06 is something that we can assign to both player and admin. So that is the case is satisfying. So in the set diagram, so it comes to this section of the diagram. Right, so when you come to the player case or 07, this large structured object we have with so many extra properties, still it's fine because structural typing, it need only the minimum required properties, which are ID and name. And now we are moving to the intersection type, and in the intersection type, in this example, so we have the case of this area, and for that area we can see any value that can be assigned to player plus any value that can be assigned to admin. So those are the only values we can assign to player and admin. Right? It's the same kind of mental model and the wording we use for the more of a simple literal type example we checked earlier. So if you follow that one, it builds up the mental model, the broad mental model we need. We are not worrying about the explicitly talking about the properties behind the scene it happens. But if you think as values, there can be a number of objects in the universe that can be satisfying this player. If you see this example here, you can add so much additional properties. Only properties we need satisfying ID and name. So if we just think about in terms of properties only, you might feel we are narrowing it down too much in our mental model, and that could affect when we come to build up more advanced types. So that covers the intersection of objects. So the key point is we have to kind of move into or shift into this model of thinking and think in terms of assignability of values. And you can see so far when we are discussing about these types, we were not too much focusing about the properties per se, but we were talking in terms of values. The reason is, as you can see in a structural typing system, there could be a number of values that satisfy a type because it only looking for the required properties defined in a particular type. And having excess properties is fine to support our JavaScript runtime behavior. So it would be more easier to build up in that model to understand the variety or the wideness of the values, the possible values for that particular type you're defining. So even though we feel like in this definition here, if I move to the player, now you might be feeling like we are defining some very narrow type of that has ID and number only. But you can see from this example that's not the case. We are defining a universe of type of player that can assign any value in the universe that satisfy the minimum requirement of this player type, which is having a property of ID type number, property name type of string. And that can be a number of values. So it's not just a value object that has only ID and name. And it can be more complicated if you go with that narrow mindset here to the more additional operation with types to understand, like intersection and union types. Then you might be making decisions that based on that narrow definition of that type. But if you go with the broader view, where here what happened is any value that can be assigned to player. So you know the structural typing. In the structural typing, you know what it is. It's only the structure in matching. So any value that matches the structure of player can be assigned. Any value that matches the structure of admin can be assigned. And any value that matches the structure of both player and admin can be assigned as well. Now, it's even that third definition of and is more wider, as you can see here, this example. Still, you can have lots of unwanted properties there and still satisfying these user types. So you can see it's never gonna fit onto a model of this type of very rigid kind of type system to represent the runtime flexibility in JavaScript. So that's why it's very important we build up that mental model of having sets. So that's more broadening of things. Once you broaden your understanding about the types, then these operations like intersection, this union here, and this is intersection here, and those kind of operation would be more intuitive to your mental model in terms of thinking what types needs to be used or what values can be assigned to those types. Now, there are some special cases. Once you get that understanding, you can understand. Now, in this example here, it should be easy to understand that intersection is something that value can be assigned to string and value can be a number, and that will never happen because that's the bottom type. So there is a no value, that's disjoint. A value can be the number or string, so it's infinite, right? And also this type here, that's something string union with never. So if we use our terminology, a value can be assigned to string or value can be assigned to never, and a value can be assigned to both string and never. So if you see in this case, it's just a string itself you are getting, because only possible, because for never you can't assign any value, but for string you can assign any string value. So it inferred as string set here.